In this video, we'll be solving systems of equations using reduced row echelon form. We will use the same 3-row operations to get our augmented matrix in reduced row echelon form as we used for row echelon form. To ensure we are performing the least number of row operations possible, we're going to be following a procedure called Gauss-Jordan elimination. It's super similar to our Gaussian elimination that we used for RREF. We'll start by writing the system of linear equations as an augmented matrix. Next, we'll use row operations to rewrite the augmented matrix in reduced row echelon form. And the procedure really is the same. We'll start by creating a leading one in the first row, first column, and then we'll create zeros below the leading one in the first column. Next, we'll create the leading one in the second row, second column, but now we need to create zeros both above and below the leading one in the second column. We'll create the leading one, third row, third column, and create zeros above and below the leading one. And we'll keep doing that until our matrix is in reduced row echelon form. We'll write the system of linear equations that corresponds to the matrix in reduced row echelon form, and the result will be the solution to the system. So let's solve using Gauss-Jordan elimination, aka RREF. You may see directions written either way: solve using Gauss-Jordan elimination or solve by putting the matrix in reduced row echelon form. We'll start by writing our system as an augmented matrix. Now, this is a long procedure, so don't write too big. Our first row, 1, -1, -2, 0. Next row, -2, 5, 10, -3. Our third row, 3, 1, 0, 0. All right, step 1 is to get a leading one, first row, first column. We have that. Now we need to get zeros below that leading one. You'll notice that there are 2 numbers that need to be changed into a 0. Just start with one of them. I usually just go right down the column below my leading one. So I'm going to start with turning this -2 into a 0. We're going to go through the same thought process that we did with row echelon form to get the row operation. I'm going to ask myself what I have to add to -2 to make it 0. 2. The leading one in this column is in row 1, so that's the row I'm going to multiply by the 2. I'm going to add it to the row that I'm trying to change, and then change that row. I always like to rewrite the rows that I'm not changing first. And now we'll do our side work to get our new row 2. I need to do 2 times row 1 and add it to row 2. 2 times row 1 gives us 2, -2, -4, 0. And we'll add that to row 2 as is. We end up with 0, 3, 6, -3. That's our new row 2. Still working on getting all zeros below our leading one in the first row, first column. We'll now change that 3 into a 0. Our row operation will be -3 times row 1 plus row 3 for a new row 3. Writing down the first 2 rows. And then we'll do some side work to get that new row 3. Going to be multiplying row 1 by -3 and then adding it to row 3. -3 times row 1 gives us -3, 3, 6, 0, and we'll add that to row 3 as is. We end up with 0, 4, 6, 0. And our column 1 is all set. Leading 1, first row, first column, zeros below it. The next thing we want to do, following our Gauss-Jordan elimination, is to turn this 3 in the second row, second column, into a 1. Remember that when creating leading ones, we typically either interchange 2 rows or multiply through by a constant. That's typically a fraction. Also remember that we only ever want to interchange with a row below the one we're working in. So if I interchange row 2 with row 3, that's not helpful. It just puts a 4 in the spot. So instead, we are going to multiply row 2 by a number that would change 3 into 1, and that number would be 1/3. So we're doing 1/3 times row 2 for a new row 2. I'll write in row 1 and row 3. Careful, this is where I usually make the mistake and write down the wrong number when I'm going from the far right of the paper to the far left of the paper. So just be careful that you're writing your numbers down correctly. Alright, so now we're doing 1/3 times row 2. 1/3 times 0 is 0. 1/3 times 3 is 1. 1/3 times 6 is 2. 1/3 times -3 is -1. We have our leading one, second row, second column, and here's where reduced row echelon form differs. Not only do we need a 0 below, but we also need a 0 above the leading one. It doesn't matter which one you do first, just make a choice. I usually work my way down the column, so I'd be inclined to turn the -1 into a 0 first. I start by asking myself, well, what do I need to multiply, what do I need to add to -1 to make it 0? That's going to be +1. That's our multiplier. The leading one in this column is located in row 2, so we'll be multiplying row 2 by that +1. We'll add it to the row that we want to change, and then we will have a new row 1. Write down my rows 2 and 3. And do some side work for our new row 1. We're doing 1 times row 2 plus row 1 for our new row 1. 1 times row 2 is just the same as row 2. And we'll add it to our row 1. And we get 1, 0, 0, -1. That's our new row 1. We have a leading one, second row, second column. We have zeros above, but we need zeros below as well. That 4 needs to turn into a 0. Our row operation will be -4 times row 2 plus row 3 for a new row 3. I'm going to write down rows 1 and 2. And then we can do our side work for our new row 3. It's going to be -4 times row 2, adding it to row 3. Negative 4 times row 2 gives us 0. Negative 4, negative 8, positive 4. And we'll add it to our row 3 as is. We get 0, 0, negative 2, 4. And there's our new row 3. Let's take a look at our matrix, see if we're getting to that reduced row echelon form. Our first 2 columns look good. Leading one first row, first column, zeros below. Leading one second row, second column, zeros above and below. But we're not quite in reduced row echelon form. We now need to create a leading one third row, third column. So we need to turn that negative 2 into a 1. There is no row below us that we can interchange with, so our only option is going to be to multiply by a number. We need to multiply negative 2 by negative 1/2 to make it 1. Our row operation is negative 1/2 times row 3 for a new row 3. I'm going to write my rows 1 and 2 down first. And now multiply my third row by negative 1/2. Negative 1/2 times 0 gives me zeros. Negative 1/2 times negative 2, that's a positive 1. And negative 1/2 times 4, negative 2. Now that we have our leading one third row, third column, we want zeros above it. There's only one number that needs change. That 2 needs to be turned into a 0. Our row operation will be negative 2 times row 3 this time, because that's where the leading one in the third column is. So negative 2 times row 3 plus row 2 for a new row 2. I'm going to write rows 1 and 3 down first. And then do some side work for our new row 2. Do a negative 2 times row 3, adding it to row 2. Negative 2 times row 3 gives us 0, 0, negative 2, positive 4. And we'll add that to our row 2 as is. We get 0, 1, 0, 3. And that is our new row 2. Our matrix is now in reduced row echelon form. We're ready to rewrite the equations, and we should have our solution. Our first equation, x equals negative 1. Second equation, y equals 3. Last equation, z equals negative 2. Remember to always write your solution as an ordered triple. Our solution is negative 1, 3, negative 2.